Hey everyone, this is Unit 1, Atomic Structure, Section 4, Electron Configuration. This video is for Honors and Gen Chem. So we've already mentioned a couple times, moving outward as we leave the nucleus, we find electrons arranged into energy levels. As we move from the nucleus outward, you're going to fill an energy level before you attempt to move to the next energy level, and there's a maximum of 7. And we can remember there's a maximum of 7 because there is also a maximum of 7 periods on the periodic table. Keep that in mind, there is a correlation. Within each energy level, there are sublevels. There are 4 possible sublevels: the S, the P, the D, and the F sublevels. And those are indicated by lowercase of that letter. So a lowercase s orbital, or excuse me, a lowercase s sublevel is a sphere. A lowercase p sublevel is kind of a figure 8. D and F are more complicated. We don't really focus so much on those shapes, but the shapes do help to understand why we can fit more electrons in P's, D's, and F's than we can in the S sublevel. So every energy level has at least an S sublevel. As you move higher in the energy levels, you add P, D, and F. We need to start looking at the periodic table more as a tool and less as just something to hang on the wall. The periodic table is designed in a very specific way. Okay, we notice that it kind of feels like, if you look at the periodic table, you have kind of this area right here. All right, you have this area right here. Okay, this area right here, and there's a reason I cut off helium, and this area right here. Okay, that kind of feels like the 4 big pieces. Helium also kind of feels like it should really fit right there, right? This is the reality of the periodic table. They are designed in this certain way because this blocking of the periodic table is aligned with the sublevels and how many electrons they can fit. The S sublevel is the one that every energy level has. Energy level 1, 2, 3, all the way down. The D sublevel is located in the middle, and it is 10 blocks across, so you could fit a total of 10 electrons in any D sublevel. The P sublevel is on this side, or this P block, and it is 6 blocks across, so you can fit 6 electrons in there. And then the F sublevel is down here. It is 14 blocks across, so you could fit 14 electrons in it. So these blocks really correlate with the electrons, and they're aligned in a certain way because of their shape. The D sublevel sticks a little bit further out than some of the S's. So when you actually are doing your periodic table, if you look on, for general, if you look on your periodic table, you'll see that over here we have a 4, nope, yep, okay. Over here, it might say 4S, and then when you move to the middle, it's actually 3, okay? If you're curious about why, we can talk about it, but for right now, I just want you to recognize that the periodic table is a living, breathing document, and it is a tool. So as we move forward in this section, make sure that you can kind of look at your periodic table so you know what I'm talking about. Every sublevel has a certain set of orbitals, which correspond to how many electrons can fit in them. So the first energy level has an S sublevel, and that's it. And so it can fit a total of 2 electrons. In the second energy level, there is an S and a P. S's can hold 2. Each box in a P holds 2, 2, 2, so 6. So any one of these boxes all the way down can only hold 2 electrons in them, okay? And you'll see as we start to move into the orbital diagram how we arrange that, but the number of boxes corresponds with the number of electrons that can fit there. And like I said, the number of boxes corresponds with the number of electrons, which also corresponds with the number of element boxes in that block on the periodic table, okay? Once you see me work through it, it's going to make a little bit more sense. So for right now, recognize that each sublevel can have these boxes, which are representative of the orbitals, and those show, or those are the location where the electrons actually get written. So just like with looking at atoms and looking at its electrons, you start at the lowest energy level when you're filling an orbital diagram. The only exception there is going to be the 4s sublevel, which I'll talk about later, but you start at the lowest energy level and fill as you move outward. Within that energy level, spread your electrons out within the orbitals until you have to double them up. So you'll notice in the first energy level, I put 2 electrons in here, and the electrons are represented as arrows. So an arrow is an electron. Okay. Once I have an arrow in there, the second electron I place in there needs to face the opposite direction, okay? Because electrons are going to repel each other. So if we have one electron facing up, the other electron needs to face down, okay? And these are just arrows representative. This is just a diagram, so it's not an actual electron, so don't worry about, trying to remember the orientation. Just remember that if I point an arrow up, I should point the next arrow down, okay? This is another one of those skills that we'll definitely practice in class, so, be ready to, but don't freak out over it, okay? You notice in the in the second energy level, there is an S and a P sublevel, and we fill those orbitals as we go across. Third energy level, there's an S and a P. We fill the S first because that's the closest to the nucleus, and then as we move outward through the P, I spread out electrons before I double, okay? And when we do practice with this, you'll see I'll work it out on the board, and so I would put the up arrow, the up arrow, the up arrow. If I had another electron, the next electron arrow would point down. So as mentioned, if what I'm kind of talking about is stretching your brain a little bit, it is totally okay to look at the periodic table as a tool and realize, okay, I'm going to look at the periodic table as a tool. I am not going to memorize, or I may be struggling with this particular topic, so I'm going to use the periodic table the way it is, okay? Remember, the S subblock, all the way on the left-hand side, is 2 elements wide. It can fit 2 electrons. The D subblock in the middle is 10 elements wide. It can fit 10 electrons. The P is 6 elements wide, so it can fit 6 electrons. And the F sublevel is 14 wide, so you could fit 14 electrons, okay? So that means in the S sublevel, you're going to have 1 orbital, okay? Because an orbital is a box that can hold 2 electrons. So in an orbital diagram, you would have 1 in the S sublevel. In the D sublevel, it's 10 wide, so I would have 5 orbitals, okay? So I would have 1, 2, disregard the evenness of this boxes, but if I were doing a D sublevel orbital diagram, it would have 5 boxes for me to put electrons in. P would have 3 orbitals because each one can hold 2, and there's 6 boxes across, and the F would have 7 orbitals, okay? And when we practice this, it'll be very, very clear. Now, orbitals are a way to visually explain the configuration or the orientation of electrons, but electron configuration is a very, in my opinion, very fun way to give almost an address of where the electrons should be found. We know from the quantum mechanical theory that electrons are really hard to track, but we do know where we should be able to find them, okay? We do know that, we should be able to find a certain amount at the second energy level, and that they should fit into, the S sublevel or the P sublevel, okay? So the electron configuration really is just the arrangement of all the electrons within the sublevels and the orbitals. So these are the steps for configuration. I'm going to talk them really quick, but then I want to actually show you on the next slide. So when you're writing an electron configuration, you figure out the total number of electrons, because that's the number of electrons you need to place. Everything always starts with 1s, because moving out from the nucleus, the first energy level you're going to get to is energy level 1, and energy level 1 has only an S sublevel. So every electron configuration must start with 1s, okay? The maximum number of electrons in an S sublevel, of course, would be 2, and it says to place that in the exponent position. So when we're doing an electron configuration, I'm just going to give you an example here, okay? That first number is the energy level. The letter is the sublevel. Oh. Sublevel. And the number that goes as the exponent is the number of electrons in that sublevel, okay? So an S sublevel can only hold 2, so if you fill it completely, it would have an exponent of 2. A P sublevel can hold 6, because on the periodic table, the box is 6 across, so it would have an exponent maximum of 6. You're going to start placing electrons at the 1s, and then you would go to the 2s, and then the 2p, and then the 3s, and then the 3p, and then the 4s, and then the 3d, which I'll show you in a minute why, and then the 4p, etc. So you move outward from the nucleus and head up through the energy levels, placing the maximum number of electrons each time. And to check your work at the end, all of your exponents really should add up to the number of electrons because that is what you're replacing. All right, so let's say we were doing the electron configuration for lithium, okay? So when electron configurations are done, you start, of course, with 1s, okay? Because we know that no matter what, any electron, even the only electron that's on hydrogen, is going to be in the 1s sublevel because that's the only energy level, and that's the lowest energy level and the only sublevel found there. So when I'm using the periodic table as a tool, because I'm starting at 1s, I'm starting at hydrogen, okay? And I'm literally going to count 1, 2, okay? So that means that I could fit a total of 2 electrons in the first energy level, so I would put an exponent of 2, okay? Because we know that helium's kind of in a weird place. As you move down, it makes more sense. So now I'm at element 2, I'm going to move to lithium, which is right here, okay? This is in the second energy level, the second period, and it's on this left block of the periodic table, so it's the S sublevel, and I only have 1 electron to place. There we go. 1 electron to place. So the electron configuration for lithium is 1s2, 2s1. If I were to keep going, let's say that I changed it to beryllium. Okay, beryllium is 1 more box over, so this would become 2s2. Okay, if I kept going across, it would become 2p, etc. So this part of the periodic table is p. This part in the middle is d. S on the left, F on the bottom. Well, I just did it because I forgot that I put it on this slide, but oh well, let's walk through beryllium, okay? Beryllium has 4 electrons, so we're going to place them. It is located in period 2, so its electrons are going to fill up into the second energy level. We know that the periods on the periodic table, the numbers down the left-hand side, correspond to the energy levels. So if something is in period 2, that means that its electrons are going to fill up into the second energy level, okay? Start with 1s always, and we count our way across the periodic table. And so again, we start with 1s, we fill the 1s sublevel because s can hold 2 electrons, and then we move to the second energy level in the s. We only need to place 2. Again, we can check our answer by adding up the exponents, which is 4 electrons, which is what we started with. So that means we did it correctly. Now you should look on your periodic table as we go through this one. We're going to look at sulfur. Sulfur is a little bit bigger, so it has 16 electrons. It's found in period 3, so it's going to go up into the third energy level. Again, we always start with 1s, okay? S can hold 2 electrons, so I'm going to place 2 electrons there, so I'm working my way down, or excuse me, working my way out from the nucleus, so 2 electrons get placed there. Move to the second energy level. First sublevel is an S sublevel. It can hold 2 electrons, so keep going. As I move across the second energy level, and again, I'm just moving straight across the periodic table. Second energy level, P sublevel. P sublevels can hold a maximum of 6 electrons, so I'm going to go ahead and place the 6 because I have a lot more than that to place. Once I've gone all the way across the periodic table, I'm going to go back to the left-hand side and start over at the third energy level. Has an S sublevel, can hold 2 electrons. So I place those 2. That has 4 left over because if I add them up, 2 plus 2 plus 6 is 4, 10 plus 2 is 12. So I have 4 electrons left. Move right across, third energy level, P sublevel has 4 electrons to place in it. And if I add up all of these, it is 16, which means I did it correctly. All right. Now I know this feels like a lot of information, but like I told you guys in class, let it flow, watch the video again, it wasn't that long, you can do it, and be sure that you've taken some notes down. If you didn't look at your periodic table the first time you watched through, watch it again please. Come in with questions, because certainly if you have questions I want to answer them, but please don't walk in and say, I didn't understand it, because that's not a question. So formulate a question. All right, see you next class.